I'm Adam, and in today's video, I'll be showing you how you can integrate Spira Team and Vectra with GitHub. In the video, we'll be covering how you can set up a GitHub repository with code and branches, how it's visible within Spira Team, how you can also create GitHub Actions, and either trigger the action from Spira Team using our Spira app to launch a pipeline with all the test results and the code running in the pipeline, and the results come straight back into Spira Team for traceability, or how the results can be triggered from a code change automatically pushing the results back in. Either way, you'll see how you take requirements, how you write code and tasks, but all that is seamlessly managed between Spira Team and GitHub in one integrated environment. Let's get started. In this video, I'm going to be showing you how you can integrate GitHub with Spira Test Team or Plan from Vectra. And in the video, I'm assuming you've already set up the integration as per the documentation. And if you go to the administration menu and you go to data synchronization, you will see that GitHub is integrated with one of our projects and is actively synchronizing every few minutes. In this video, I'll be showing you three parts of the synchronization. Firstly, how we can synchronize issues between the two different tools. Secondly, how we can synchronize builds and CI events and have test automation results come back. And thirdly, we'll also look at how you can have the source code integration enabled so you can browse GitHub source code repos directly from within Spira as well. So starting off at the beginning, let's first of all connect the issue tracking side of the tools. If you go to the GitHub project that you set up and we go into the main artifact menu, we can go to the issues or incidents section of Spira. And if we log a new incident in Spira, perhaps we found a new bug during testing, and we want to push it over to the GitHub team where the developers will be working on it, then we will obviously want to do that here. So let's go ahead and put in the new name of the bug, which would be, say, example, found a bug on the login screen. We'll class that as a bug. We'll look at the releases, and these releases are connected to the milestones in GitHub. So we'll say release 1, release high. I'll do a simple one as I was trying to log in and found a bug. Let me hit save. It's a very basic one. And as I mentioned, this could also be during testing, so we can have a look at that as well. Let's go into our test case section, and let's pretend we have a manual test case, and we were executing it, it failed. So we'll take this very first one. We'll go to Tools, Execute Tests. I will choose the release. If I look at the build menu, you'll see there are a list of CI events. Because we've already integrated this with GitHub, you will see any CI events that have occurred. And that way, if this particular test is linked to a specific build, then you can tag that right here as well. We don't need to do that. And let's go ahead and let's click on the test and see what happened. We were meant to be able to add a list of books into the system. We'll pretend it failed. And we'll say, failed to add a book, received the error message, system not available, HTTP 500, something like that. We'll also want to log a defect associated with this. So we'll go to incidents, and we'll put the name of a bug, which would be enable to create a book in the system. Go to bug, priority high. We'll hit fail. Excellent. And now you'll see we've now logged 2 defects. Okay. And we've got a failed test result here as well. If we go into the incident section of Spira, we'll see we have our 2 bugs. I'm going to sort by most recent. Here's the bug that we entered directly. And here's the bug that we logged through testing. They look similar, except the one that we logged through testing has a description, expected result, actual result, and list of steps. So it's got a bit more information in the description. We can also go here into GitHub and into our same project, and we can maybe log an issue on this side as well. You can see our 2 bugs have actually disappeared while we were doing that. But let's go and test the reverse direction. And the developers logged a bug that we might want to link to a test case or a requirement. So was trying to browse the home page and had an error. When I tried to browse the application homepage, I received a 500 error, or 404, I guess it might be. That makes it different. And I will create that. Let's assign it to a milestone. For anti-milestones, we can leave that. If any other tags or labels, we can do that as well. I'll keep it basic. And I've logged that here. And while that's being synchronized, let's look at the ones we just created in Spira. And you can see that we've actually got this item now. This is the one that I created the book right here with the steps. And you can see it's got the markdown syntax. So the formatting that we saw in Spira is maintained here in GitHub. If I go back to the other one, the one that was logged outside of testing, the simple name, you see that's also been created here as well. So really easy. That's the name right there. There's a description. We can add comments. I go back here in Spira and hit refresh. You'll notice we now have a GitHub ID and an attachment, which is a link to the item in GitHub. And if you go here, the same is true. So the nice thing is it makes it really easy to be able to work in the two different systems. I can log a bug in either one, and the synchronization keeps them bidirectionally updated. So that's the defect issue tracking integration. The second part of the integration is around code, and I've done that as well. So I went into the administration section here, and I went into my source code, and I've hooked it up to my GitHub repo. I use the clone URL, login, and the password, or actually in this case, API key or personal access token, which is masked. And so now, because I've done that, if I go into source code, I can see the source code right here in Spira, which will mirror that in GitHub. I can choose the different branches that we have, pick a branch. I can look at any of the code. This is sample Python code. You can see we've got syntax highlighting right here, which is very nice. If I go in the commit view, I can also see any of the commits. And if those commits are tagging a Spira artifact, like a requirement or a task, those are clickable. So I can bring those up here and here. And I'm now bringing up my Spira artifacts. So I can see this is my requirement. If I go to my associations tab, you can see there is a link to the commit. I go to my task, go to the same tab, the associations tab. You will see there is a link to the commit there as well. So that's great. And if I go back a second to my code, I can also, if I want to drill down and see what code changed, I can go into the view, which shows me these are the 3 files in this commit. And if I was to click on one of them, let's pick the main file, I can see in the change history exactly what changed with a nice syntax highlighting and change difference tracking. I can see unified, I can see a left-right split view, whichever you prefer. I can also see the before and after view as well, which is nice. So it's got full code highlighting, syntax highlighting, full code browsing, and you can tie any of those code changes to artifacts in Spira, giving you that traceability from a requirement, a task, or an incident directly to the lines of code that were changed in both directions. And the last part of the integration is the CI pipeline. So if you're using GitHub Actions, which many of our customers are using, then you can also integrate the actions into Spira. And typically in a pipeline, if I go over here to my pipelines, you might have a situation where you have a pipeline which is going to compile the code or build the code, depending on the language it is. It's going to run some unit tests, and you want those unit tests to report back into Spira. So I have an example of that here. If you go to the file system, you can see there's our project. We've got some sample code, which is in Python, which is being built in the pipeline. And then I've got a unit test. And in that unit test, I've got a sample JComplete unit test that's being run. It generates a unit test file. So this is an example of a JUnit or XUnit style test report. It's got all of the tests being run. It's got screenshots, other information. All of that is being generated by my unit test. And then when that test is run, I really want this XML file to appear in Spira. I also want a full list of the build steps to be in Spira and all the list of any of the source code commits that made that change. So let's imagine we go in here and I'm going to make a one-line change. So I'll go into my configuration file. I'm just going to change the comment and I'll just add another line just to force it to build. I'll save that. I go into my source code management tool. I'm using Git-Kraken, but any tool is good. I go in here, stage the file, add a comment, test, build, commit that, push it, must need to push it to the remote branch. That's now going to trigger GitHub to start building. So if I go over to GitHub, I go to my actions, you can see my code commit has just triggered a build, which is fantastic. That build is going to run. And inside of GitHub, we do have the Inflectra webhook enabled, which is over here. And that's what's going to be used for triggering the results to send back into Spira. And when that webhook runs, it picks up the code change, it picks up the build, and it will send all the information seamlessly back into Spira. So let's go see how that looks. I go into my releases section. I can see that I go to release 1. I go into scroll down to my build section. You will see here we've got this new build that just reported. So we ran that unit test. We've changed the code. So let's first of all look at the workflow. You can see here, there's my commit. And if I want to see what was in that commit, I can click on it. And it's going to show me there was the config file. I click on it. It's going to show me if there are any changes. Let's see if there are. Oh, it's a config file. We can't view config files. If I changed a JUnit file or a Python file, it could show that. This is not one of the file formats it supports for security reasons because it's got some security information in there. So let's go ahead and go back to the build a second. If you see that, that was the commit that we used to trigger the build. So we do see the files, and I can see the hash that was involved in that. If I scroll down, I can see when that was done as well, and which action it was in, and that's a link to the action. Similarly, if I then go back into my releases one step backwards, you will see there's a second entry, which is the test results. That's been pushed in by the XUnit integration, and you can see we've run some tests, and you can see we have 8 different tests. 5 have passed, 1 is blocked, 1 is marked as not A, and 1 has failed. So that's great. So you can see right here my test results have been pushed. If I click on a failure, you can see exactly what happened. There was a login page missing, which is great. I go into my test result in my test set. Let's go and do that. I can see the attachments. There's my screenshot. And all that is now reported seamlessly back here into my test result. And I can obviously go into the overview and see exactly what page has changed. And I can see which test case this was for and all the previous runs. I can see which test set it's part of as well and all the runs there. So I've got traceability from this automated test ran in my pipeline from GitHub. Now, I did trigger that in GitHub using a tool to make a change in the code and hit commit. That's great when developers are making active changes in the pipeline, which will trigger automated builds. But sometimes as a tester, you want to trigger the build because you've made maybe a configuration change and you want to just verify that the build still works. You don't want to have to mess with the code repository and make artificial changes for it to run. So that can be supported as well. To do that, we have a Spira app available on our marketplace, which is completely free. You connect it into Spira and enable it. And when you do that, if you go into the release right here, instead of going into Git Kraken and into Visual Studio Code and making a fake change I can remove the line, obviously, I can go in here and I can choose the option instead to trigger the build and run the action. So I'll do that right now. That successfully starts my GitHub pipeline. That's going to kick off the build. If I go over here into GitHub Actions, you will see it is running right now. And I'll go back here and refresh the page. And you'll notice there is now another build entry. Notice there's a difference, though. The first time around, we created 2 different build entries that when the second one had a commit in it. So this is the one which I created by making the code change. You'll see that there's a commit entry, which is the commit that triggered the change. If I go back to the release, I look at the exact same line, but for the second entry, where I triggered it from the Spira app, you'll notice that there is, in fact, let me go back a second. Make sure I get the right one. And go over here to this one. Yep, 87. Right. You will notice there is also going to be a trigger because it does take the last commit in GitHub. So we've triggered commit the build to run in GitHub, and I believe it does pull the most recent commit as part of that. So just to note that we are kicking off the build from either GitHub or from Spira. And you kick it off by making a code change in GitHub or in Spira. You just simply go to the action and kick it off. Notice that we do include the commits. We do run the tests. If I go to the test results, you'll see we've got those same test results here. It is reading that XML file. And I can now review the test results, review it back to the tests that will run, and those report back to my requirements. If I look at my requirements in Spira, you'll see that my manual test that I ran, which then caused me to log a defect in GitHub, those are listed here. But also any of the automated tests that are running as part of my pipeline, they're also coming back here. So I have a nice singular view of all the test results in Spira, whether it's a manual test being run in Spira, pushing bugs into GitHub, or it's automated pipelines running with some of the unit tests and other code level tools. And if I go to my test run section, I've got a nice holistic view of all the test results, both manual and automated in the system. And I can look at the manual ones right here. I can look at the automated ones right here, all in one place. And if I go to my dashboard, I've got a nice roll-up view of all the key metrics in this project, including code, bugs, and of course, defects being logged. And I've got my testing view and my development view. In the development view, I'll see all the builds that ran, and I will see the code commits here as well. In the testing view, I will see the manual and automated tests run through either the pipeline if they're automated or by human if they're manual. So that's our GitHub integration. As you can see, it's a really powerful integration. It combines the code, defects, and actions all in a singular view. And depending on the way you're using GitHub, you can use all those different integrations or just some of them. For example, some clients might be using GitHub for code management, but might be using Jenkins for the build. You can do that, of course, and use our Jenkins plugin instead of the GitHub Actions. So you can mix and match the different plugins that we have. Similarly, you might be using GitHub for code, but maybe Circle CI for build. Same thing, we've got an equivalent plugin for Circle CI as well. So thanks for watching today's video. Look forward to seeing you on future videos.